Welcome. In this video, we are going to use the ratio test to determine whether or not this series here converges or diverges. So recall that when using the ratio test, we're interested in this limit. Now, if L is less than 1, then the series converges absolutely. If L is greater than 1, the series diverges. And if L equals 1, the test is inconclusive. So the first thing we want to determine is the ith term. That's 2 to the I divided by I factorial. And then the next term, that's the ith plus 1 term, that's 2 to the I plus 1 divided by I plus 1 factorial. Okay, so now let's figure out what this limit is. So the limit is, in this case, I will use I. I approaches infinity, and not the imaginary I. I is an index, as a symbol, as a variable that's growing and growing to infinity. So the limit as I approaches infinity of the ith plus 1 term divided by the ith term, that's equal to the limit as I approaches infinity of 2 to the I plus 1 divided by I plus 1 factorial. In the numerator, in our denominator, we have 2 to the I over I factorial. And now recall that factorials, you multiply the integer n times 1 minus the integer, so 1 less, times 2 less, and so on. You keep on multiplying until you get to the number 1. So of course 4 factorial is 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. And then n plus 1 factorial, in fact, is equal to n plus 1. Then you want to ask yourself, well, what is n plus 1 minus 1? Well, that just equals n. So that would go times n here, times n minus 1, n minus 2, and so on. And so what you really end up with is n plus 1 times n factorial. Let's use all this information now here to clean up this limit a bit. And when I say clean up, I'm just using, slang for simplify everything. Make it look neat and easier to work with. So this is the limit as I approaches infinity of 2 to the I plus 1 divided by 2 to the I times I factorial divided by I plus 1 times I factorial. So these will cancel. And then we have a 2 to the I here, 2 to the I, leaving us with a 2 in the numerator. So this is 2 times the limit as I approaches infinity of 1 over I plus 1. This limit is certainly 0. So L is equal to 0, and that is certainly less than 1. So that puts us here in this case. All right, so now we know that this series converges absolutely. And this is by the ratio test. I hope this video made you happier than a rainbow at a unicorn parade.